In this video, we are going to solve some examples on concentration of solution. And the first example is calculate molality and mole fraction of the solute in aqueous solution containing 3 gram of urea, molar mass is 60, per 250 gram of water. So there is one solution which contain 3 gram of urea and 250 gram of water, and we need to calculate molality of solution and mole fraction of urea. Now what is given? Weight of solute, that is urea, it is given, and the weight is 3 grams. Weight of solvent, that is water, it is 250 gram, and molar mass of solute is also given, that is 60. Molar mass of water is known, that is 18 if required. Molar mass of water is 18. Now first of all, molality of the solution. So molality, it is equal to W2M2. So W2 it is a weight of solute, M2 it is a molar mass of solute. Here solute is urea, and weight of solute upon molar mass of solute, this gives number of moles into 1000 upon W1. So this is the formula for molality. Now each terms are known. Weight of urea, it is given, that is 3 grams. Molar mass of urea is also known, 60, and weight of solvent is also given, that is 250. Just to substitute the values, so molality equal to 3 upon 60 into 1000 upon 250, and when we solve this, answer is 0.2 mole. So molality is 0.2. Now another term, that is mole fraction of the solute. Here solute is urea, and mole fraction, it is the ratio of number of moles of that component upon total number of moles of all the components. And mole fraction of solute, it is equal to number of moles of solute upon number of moles of solute and solvent. So first of all, find out the number of moles of solute, that is urea. Now 3 gram of solute means 3 gram of urea corresponds to or equal to 3 upon 60. Actually 3 it is the weight of solute and 60 it is the molar mass of urea. So weight upon molar mass, this gives number of moles. So 3 upon 60, it is equal to 0.05 mole. So these are these many moles of urea present in the solution. Total number of moles of solute present in the solution. Now number of moles of solvent, actually here solvent is water. So 250 gram of water, it is equal to 250 upon 18 moles, weight of water upon molar mass of water. So this gives number of moles. Now when we solve this, it comes 13.87 moles. So 13.87 moles of solvent is there, and 0.5 moles of urea, that is solute, is there. Now mole fraction of solute is asked. So mole fraction of solute, that is X2, it is equal to N2 upon N1 plus N2, where N1 is number of moles of solvent and N2 is number of moles of solute. Just to substitute the values, so value of N2 is 0.505, so 0.05 upon 0.05 plus 13.89. When we solve this, it comes 0.00359. This is the mole fraction of urea, that is solute. Now mole fraction of water, how we calculate? Just to subtract this value from 1 minus this, that will be the mole fraction of water. But in this example, mole fraction of urea is asked, and this is the answer. Now next example, calculate the molarity and normality of a solution containing 0.5 gram of sodium hydroxide dissolved in 500 cubic centimeter. So this is the volume of solution. Now here weight of solute is given. Solute is sodium hydroxide and its weight is 0.5 gram and it is dissolved in 500 cubic centimeter of solution. The weight of NaOH is given 0.5 gram and volume of solution is 500 cubic centimeter. Now the formula for molarity is, molarity, it is a concentration where gram moles of solute dissolved per liter of solution, and the formula is M is equal to W2 upon M2. This is actually W2, it is a weight of solute, M2 it is a molar mass of solute. So this ratio gives the number of moles of solute. So W2 upon M2 into 1000 by V. V is a volume of solution in cubic centimeter. Now we know the weight of solute, we know the molar mass of solute. Molar mass of NaOH is 40. So just to substitute the values, 0.5 upon 40, 40 it is a molar mass of sodium hydroxide into 1000 by 500. So volume of solution is also given and the answer is 0.025 molar. So molarity is, so this much is the molarity, 0.025. Now next is normality. Now normality, it is a concentration where gram equivalent of solute present in or present per liter of solution. This is the normality. And how we find out the gram equivalent? Weight of solute upon equivalent weight. This ratio gives the gram equivalents. And the formula for normality is W2 upon equivalent weight into 1000 upon V. V is a volume of solution in cubic centimeter. For sodium hydroxide, molecular weight and equivalent weight is same, that is 40, and therefore when we substitute the values, then it is equal to 0.5. This is the weight of NaOH, equivalent weight of NaOH is also 40 into 1000 upon V. V is a volume of solution and therefore normality is also equal, that is 0.025 normal. For sodium hydroxide, molarity and normality is same and answer is 0.025. Now next problem, a solution contains 25% water, 25% ethanol and 50% acetic acid by mass. Calculate mole fraction of each component. There are three components. One is water, other is ethanol and third component is acetic acid, and percentage of each component is given and mole fraction of each component we are going to find out, mole fraction. First of all, you consider total mass of solution is 100 gram, and if it is 100 gram, then there is a 25% water, means in 100 gram contribution of water is 25 gram. So amount of water is 25 gram. Amount of ethanol will also 25 gram and amount of acetic acid will also, it will be 50 gram. So total of this, it is 100 gram. In 100 gram 25% water means 25 gram water is there, 25% ethanol, meaning of this is there is a 25 gram ethanol and there is a 50% acetic acid. It means 100 gram of solution contain 50 gram of acetic acid. So this is given. Now number of moles of water, first of all we find out. So 25 gram water is there and weight of water upon molecular weight of water, this gives the number of moles. So 25 upon 18, 18 it is the molar mass of water. So when we solve this, it comes 1.388, these many moles of water present in the solution. Similarly, number of moles of ethanol equal to weight of ethanol, that is 25, upon molar mass of ethanol, that is 46. It is equal to 0.543 moles. So 50 gram acetic acid means number of moles equal to 50 upon 60. 50, it is the weight of acetic acid, and 60, it is the molar mass of acetic acid. When we solve this, it comes 0.833 moles. So number of moles of water, ethanol and acetic acid is known now. Now mole fraction of water, it is equal to number of moles of water upon total number of moles of all the components, that is water, ethanol and acetic acid. So number of moles of water, it is 1.388, and sum of number of moles of all the components, it is 1.388 plus 0.543, this is for ethanol, plus 0.833, this is for acetic acid. When we solve this, it comes 0.503. This is the mole fraction for water. Now mole fraction for ethanol, number of moles of ethanol, it is 0.543 upon total number of moles of all the component, already we solved here, that is 2.764. So this ratio, it is the mole fraction of ethanol, it is equal to 0.196. And similarly, mole fraction of acetic acid, it is equal to number of moles of acetic acid, it is 0.833 upon total number of moles, it is 2.764. After solving, we get 0.301. This is about the mole fraction of water, ethanol and acetic acid. Now next problem, very simple one. 5 gram glucose, its molar mass is given, that is 180, is dissolved in 75 gram of water. The mass percentage of glucose is. Now percentage by mass, it is the parts by weight of solute present in 100 parts by weight of solution, and its formula is percentage weight by weight, it is equal to mass of solute upon mass of solution into 100. Now mass of solute is 5 gram and mass of solution, it is mass of solute plus mass of solvent, that is 5 plus 75, that is 80. So all these values are given, just to substitute the values. So percentage of glucose, it is equal to 5 upon 5 plus 75. 5, it is the weight of glucose, and 75, it is the weight of water. And when we add this, this will be the mass of solution. And after solving this, we get 6.25%. So glucose solution is a 6.25%. Next example, calculate the concentration in parts per million ppm when 10 gram of potassium chloride dissolved in 1000 kilogram of solution. Now here we are going to find out the concentration in ppm, parts per million. Weight of solute is 10 gram and it is dissolved in, weight of solvent is given, it is dissolved in 1000 kilogram of solution. So where mass of solute is given 10 gram, mass of solution is given, that is 1000 kilogram. Actually it is equal to 10⁶ gram. ppm, it is equal to mass of solute upon mass of solution into 10⁶, and ppm, it is equal to 10 upon 10⁶ into 10⁶. This 10⁶, 10⁶, it will cancel and it will be 10 ppm. So concentration of solution is 10 ppm. Meaning of this is concentration of solution containing 10 gram KCl in 1000 kilogram of solution, it will be 10 ppm.